Good morning, students. Our next topic is process scheduling queues. So today we are going to discuss about process scheduling queues. In the last class we have discussed the use of process scheduling. In process scheduling, what happens when a process is to be kept in the ready state, when that process is to be kept in running state, when it is to be kept in waiting state. So all those things will be scheduled. So that is we simply call it as process scheduling. Okay. Our next topic is process scheduling queues. So the process scheduling queues, in process scheduling queues, we'll have three varieties of three different queues were there. They were nothing but job queue, ready queue, and device queue. We will see them in detail. So in job queue, what else will be there in job queue? In job queue, all the processes that exist within the system, all the processes that exist within the system. All the processes that exist within the system. So all the process that exists within the system will be kept in job queue. Coming to the ready queue, okay, out of all these processes, there will be some process which are in ready state to execute. Okay, so the processes which are kept in the main memory, the processes in main memory. The processes which are kept in the main memory will be placed in the ready queue. Coming to the device queue. So in device queue, what processes will be there? The processes while executing or when a process is under execution, meanwhile if it needs to perform any IO operation, those processes which are supposed to undergo the IO processes, those processes will be kept in this device queue. So the processes which needs to perform IO operation. Okay, those will be kept in the device queue. Okay, for example, if you see, we have secondary memory. Okay, the secondary memory device is the external hard disk or external hard device. Okay, all the devices which can be connected externally comes under secondary memory devices. Okay. So we have secondary memory. Next we have main memory, and next we have CPU. So next to CPU we will have cache memory. For time being, so here we will be discussing about secondary memory, main memory, and CPU only. Okay. So some IO operation. So first, all the processes which are inside the system will be placed in this secondary memory. Okay, so the job queue is nothing but all the processes within the system will be placed in the job queue. Means all the processes which are in the secondary memory. So the job queue consists of the process which are in the system. So they will be available in secondary memory. Okay, coming to the main memory, the process which are ready to execute, those processes will be kept in main memory. So the process which are in the main memory, okay, those processes will be in ready queue, will be kept in ready queue. So CPU will be, if CPU is executing a particular process, okay, if CPU is executing a particular process, after the completion of that particular process, one from the ready queue will be sent for execution. We will see. Okay. Right? So what we are discussing is, so see here, so we will have a process. So first, here all the set of processes will be available, and here all the processes which are ready to execute or which are placed in the memory, all the processes placed inside the system, all the processes which are kept in the main memory. So here, so when CPU is executing, suppose CPU is executing process P1, okay, meanwhile if this execution is over, then this will be terminated, okay, T is nothing but terminated, that process P1 is terminated, then one from the ready queue will be given to the CPU and CPU will start executing that. Let us suppose CPU is given P2 and P2 is being executed by CPU. Meanwhile, if P2, the process P2 has to undergo any IO operation, then this will be kept in device queue. Then this process P2 will be sent to device queue. And meanwhile, another process from the ready queue will be given to the CPU and CPU will continue its execution. This is what happens inside the process scheduling queues. Okay. So again we have specified what is the use of job queue and what is the use of ready queue and device queue. Okay. So pictorially we have shown here, read, see here. So here pictorially we are representing here. So we are very much familiar with the CPU. What the CPU will do? CPU will keep on executing the processes which are in the ready queue. Let us suppose here process P1 is given to the CPU. Okay, CPU has completed the execution of process P1. So here it is terminated. So the execution of process P1 is successfully completed. See here, ready queue consists of all the list of processes which are kept in the main memory. All the processes which are in the main memory will be kept in the ready queue. Let us suppose the ready queue consists of number of processes. Let us suppose inside it has P1, P2, P3 and so on. Let us suppose P1. So we have given P1 to CPU. CPU started executing P1. P1 is executed successfully. So we have terminated process P1. Next another process. Let us suppose P2. P2 was given to CPU. Okay. So CPU is executing process P2. Okay. Meanwhile, an IO request. P2 has to perform some IO request. At that time, the process P2 will be sent for IO request. See here. So CPU is executing process P2. Meanwhile, it has to perform some IO request. So this process P2 will be sent for IO request. So here all the processes which were requesting for IO, they have a special queue, that is IO queue. So this process P2, its cage has kept an IO request and it was sent into the IO queue. Okay. After undergoing this IO operation, again that process P2 will be kept in the ready queue. See here how it's happening. So first, whatever the processes available in the ready queue, all those processes will be executed by the CPU one by one. First, let us suppose CPU started executing the process P1. So let us assume that it has executed successfully. So we have terminated process P1. Okay, fine. Next, The second process P2 is given to the CPU. So CPU started executing process P2. Meanwhile, while executing process P2, let us assume that the process P2 has to undergo some IO operation. So it has kept an IO request. So that IO request was kept in a queue. So after undergoing that IO operation, again this process P2 will be kept in the ready queue. Okay. So this is the use of this IO request, IO queue and IO operation. Next, then what about this time slice? For every process, there will be some time bound or time slice. We simply call it as time slice. So suppose, time slice means within that period, the process has to be executed. Okay. Let us suppose if a process P2 has given a time slice like 4. Okay. So if the time slice is expired, but yet if the process is not executed, so once again I am repeating, let us suppose there is a process, let us suppose process P2, it was given a time slice like 4 milliseconds or 4 seconds. Okay, actually it is 4 milliseconds. For our convenience we can call it as 4 milliseconds or 4 seconds. So for process P2, if we have given 4 milliseconds, okay, so it was executed for 4 milliseconds, but yet it was not executed successfully. So in that situation, what we have to do is, we have to place that process in this time slice expired, means it has given some time slice, but it was not executed, means the execution is not completed within that stimulated time. That is what this time slice expired means. So we have to keep that process inside this time slice expired. Coming to the fourth, so if the CPU is executing a particular process, let us suppose CPU is executing process P3, let us suppose. If CPU is executing a particular process, meanwhile, if it has created a child, fork a child means creating a child. So if this process P3, let us suppose CPU is executing process P3. So during its execution, okay, if this process has created a new child, okay, then what happens? This process P3, if it has created a new child, it has to wait till the child executes, till its child executes. Okay, when its child executes, then this process P3 again it can go to the ready queue and it can continue its execution. Okay, so process P3, so P3 is being executed by the CPU. Meanwhile, if it has created a new child, 4K child means it has created a new child. If it has created a new child, what it has to do is, that process P3 has to wait till its child completes its execution. Okay, once its child has completed its execution, then this process P3 again it can go to the ready queue and it can go for the CPU to get it executed. Okay, and coming to the last one, interrupt. So while executing a process, let us suppose a process P4. If the CPU is executing process P4, if an interrupt occurs, we have already discussed an interrupt. What is an interrupt? An interrupt is nothing but it's a signal sent by the IO devices. Okay, what is an interrupt? An interrupt is nothing but a signal sent by the IO devices. Let us suppose if the CPU is executing process P4, meanwhile if an interrupt occurs, okay, so we have to wait for that interrupt. This process has to wait for that interrupt, and that interrupt will be executed. Okay, suppose if we are taking the class, suddenly if a circular, suppose if any attender comes and if he gives us the circular, what we do? We will stop our class. We will take the circular and we will read the circular and we will give back the circular and we will send him. After sending him, again we will continue our class. Similarly, so the CPU is executing process P4. Suddenly an interrupt has occurred. So what we have to do? This process will be stopped and that interrupt will be handled. After completion of that interrupt, again this process will be sent to the ready queue and again this process will be executed. This is what happens, right? So hope you have understood the representation of process scheduling. Okay. So next, process scheduling. There were different process scheduling algorithms were there. Means, so when a particular process is to be kept in ready state, when it is to be executed, when it is to be kept in waiting state, like that. In order to follow any policy, we have different strategies, different, see, here we have different policies were there, out of which FIFO, first in, first out, SJF, shortest job first, round robin scheduling algorithm, priority scheduling algorithm, etc. We have different scheduling algorithms were there. For example, if you see, we will see all these in detail with an example. For time being, I will tell you what is what. For example, if you see FIFO, first in, first out, the element which comes first or the process which comes first will be executed first. Okay. So similarly, round robin. Here, what we do is we'll have different processes. Okay. Let us suppose we'll have different processes like P1, P2. P3. Suppose if the burst time is 4, 5, 6, if this is the burst time. So here there will be a time slice, or we can also call it as time bound. If the time bound is 2 seconds, then what we do is we will execute P1 for 2 seconds, P2 for 2 seconds, P3 for 2 seconds. Again we will go back. We will execute 2 seconds P1, 2 seconds P2, 2 seconds P3. Again we will go back. So 2 plus 2. So this is over. So we need not go. So here only 1 second is enough because 5 seconds is required now. The burst time is 5 seconds. Already 2 plus 2, 4 seconds. We have executed. Only 1 second is balance. So here 2 seconds. Like this we will go. That is round robin. Coming to the priority scheduling. Priority scheduling. We have already seen priority scheduling. Again in priority scheduling we have seen preemptive, priority scheduling with preemptive, with non-preemptive. Okay, based upon the priority. Okay, so at arrival time 0, what are the processes available? Suppose at arrival time 0, if process P1 and P2 is available, so we have to execute the process which is having highest priority. Okay, and suppose at time interval 1, if there are 3 processes P1, P2, P3. If there are 3 processes, so out of these, which one is having highest priority? We have to identify the process which is having highest priority. That particular process is to be executed. Okay, this is what priority scheduling algorithm means. And we have one more, that is SJF, shortest job first. Suppose if you have different processes like P1, P2, P3. Suppose the burst time is 4, 5, 2. Shortest job first. We have to identify the process which is having less burst time. So in this example, P3 is having less burst time. So P3 has to be executed first. Next P1, next P2. Like that, the process takes place. So what the author is telling, what the author is trying to tell is, so in process scheduling queues, we are going to, here in process scheduling, we have different process scheduling algorithms out there. They are nothing but FIFO, first in, first out, SJF, shortest job first, round robin scheduling algorithm, priority scheduling algorithm, etc. We have different scheduling algorithms for there. In the coming classes, we will see all those in detail with an example. Okay? Okay. So next, last is, the author is telling there are 2 process states or 2 process models were there. They are nothing but one is running and the other is not running. Okay, one is running model and the other is not running model. So running model is nothing but the process which is already kept in ready state and it is in running state, means it is under execution. Okay, that is simply called as running state. And the other is sometimes the process may be kept in waiting state okay, or it may be performing some IO operation. All those things comes under non-running or not running. See, process that are not running are kept in queue, waiting for their turn to execute. Okay, they will be waiting for their turn to get executed by the CPU. So these are something about process scheduling queues. Okay, thank you.